Hi everyone. My name is Yi-Hao, and today I'm going to present you PeriText, utilizing peripheral vision for reading text on augmented reality smart glasses. And this is a joint work with my advisor, Professor Mike Chen, and my lab mates in National Taiwan University HCI lab. So first of all, to understand what the peripheral region is, let's take a look at the human vision system. As you can see in this figure, the human vision system can be categorized into central, paracentra, and peripheral vision in general. The central visual field with an eccentricity of 2.5 degrees is where we can see things more clearly, while the peripheral vision has lower visual acuity. Next up, what is augmented reality? Augmented reality, aka AR, means superimposing virtual objects and information onto our real-world view. AR can be very helpful in many ways. It seamlessly conveys more detailed and useful information in real time. For example, receiving instant messages and notifications. However, when the information is too overwhelming and we only have too many things to display through AR, things may end up occluding user's central visual field, and in many cases, resulting in severe safety issues. Many previous research display the content off-center to avoid occlusion. For instance, hollow content is a proposed method that proactively manages movement of multiple elements, such as emails, texts, and notifications, to make sure that they don't interfere with interpersonal interactions. However, such interfaces mainly require the user's pupil to physically move off the primary focus to the side and use their central vision to view the information, which might cause safety concerns and social acceptance issues. Therefore, some other research also proposed the design of less penalty peripheral display. One recent work explored the information visualization in the near place from eyes, which installed a tempo-closed display on a pair of glasses. Inspired by these prior works, in this work we try to facilitate reading text on augmented reality glasses using peripheral vision. This way, users' central visual field can be preserved and their pupils don't need to move toward periphery. To achieve this, we conducted 3 studies. First, we studied the effect of different text transformation on peripheral reading, because as mentioned earlier, our peripheral vision has lower visual acuity, and we aim to promote the reading efficiency. The better transformation settings then be combined and applied for the design of our proposed text interface, PeriText. We then conducted a second lab study to compare the performance of our proposed technique and the control text without any transformation. After we finished our lab study, we then evaluate our visualization on AR glasses in the real-world scenario. We use RSVP paradigm to display text on AR glasses. RSVP is short for Rapid Serial Visual Presentation, where the text is displayed word by word, anchored in the center. Let's see a demo. So here's what RSVP looks like. Under the RSVP paradigm, we explore 3 design factors of text reading interface, including text transformation, text position, and RSVP settings in our study 1, which we aim to find a better transformation for peripheral settings. For text transformation, we include full capitalization form, the title case form, the serif font, the character-wise typewriter effect, and word-wise typewriter effect. We compare these 5 designs with non-transformation control text. For the text positions, we chose 5 degree and 8 degree of eccentricity, where the text is placed in the lower visual field. For RSVP settings, we include 1 word, 2 word, and 3 word presented at a time on the field. Let's look at the demo again. So here's 1 word at a time, and 2 word at a time, and then 3 word at a time. We conclude 4 key design questions on peripheral reading text interface. First, should we present 1, 2, or 3 words at a time? Secondly, which capitalization scheme should we choose? Full capitalized or title case? Third, should the font be serif or non-serif? And finally, which typewriter animation for text presentation should we choose? All of these questions and corresponding answers are crucial for our final design. For experimental settings, we use the desktop-mounted eye tracker device on the monitor as apparatus to do rapid comparison before different designs. Before study, the observer were asked to look towards a red cluster for calibrating and calculating the offset of the device. We will discard a trial if the number of eye precision samples there away from the mean of calibration samples by 2 standard deviation. We calculated the reading good proof from 14 participants using text interface designs combined from 3 design factors. For each condition, there were 10 sentences, resulting in a total of 340 sentences per participant. The participants was asked to read out what they saw, or they say they can saw it. For the good proof value calculation, the period from showing the sentence to the participants reading it out was recorded, and the answer was typed into a text file immediately for further comparison. Based on the results from study 1, we then can answer 4 key design questions. For proper number of words shown once at a time, the results show that multiple words shown at a time significantly outperform single word shown at a time. For a capitalization scheme of text transformation, title case outperform full capitalizations and control group. For font style of serif or sans-serif, sans-serif outperforms serif font. For applied animation methods, word-wise typewriter animations have better performance over both character-wise typewriter and control group. According to these good proof results and analysis, we designed PeriText, a multi-word reading interface for peripheral reading to be title case, sans-serif, and with animation of word-wise typewriter effect. Let's see a demo of it. So please gaze at the red cluster and see if you can read text presented by PeriText. So with the proposed design, we then conducted our second study to compare PeriText and control text with the similar experimental settings in study 1. We verified the performance using PeriText under 2 eccentricities, 5 degree and 8 degree compared with the control text. There are total 8 participants, and each participant read 20 sentences for each condition. Here is the demonstration of our compared design. Left is our PeriText design, and the right is our control group, with no text transformation applied. Notice that we display 2 words at a time using RSVP, while PeriText has word-wise typewriter animation. So the word there, in this example, appears later than hello. As for control group, the 2 words are displayed at the same time. We're calculating the reading good proof from 8 participants under different conditions. The results show that PeriText achieved significantly higher good proof values than control text for both 5 degree and 8 degree eccentricities. To further understand how PeriText performed in real-world settings, we designed a field study where users wore AR glasses and PeriText and walk around on the university campus. During the study, we collected users' feedback on reading text using PeriText and AR, and the user's preference of text positioning. We provide text stimuli at 2 positions, 5 degree and 8 degree eccentricity. The study contains 2 walking scenarios. One is light loading task, in which users are on pedestrian-only walkways and meanwhile reading the text presented by PeriText. The other is heavy loading walking task, in which users have to cross the street where there would be bicycles and other vehicles. The participants were always accompanied by 2 experimenters during the study, since the safety concerns. The participants was asked to put on Microsoft HoloLens, a hand-mounted display with eye tracker by Popo Labs, to detect the user's conscious and unconscious glances toward the peripheral text. After user finished the 20 trials for each condition, we first collected NASA TOEIC index ratings, including the following 6 aspects: mental, physical, and temporal loading, as well as performance, effort, and frustration. Then, we interviewed participants with the following 2 questions. First one was, do you think PeriText is useful? And would you like to use it again in the future? The other question was, which one do you prefer, displaying at 5-degree or 8-degree eccentricity? We calculated reading throughput under 4 different conditions. The throughput result shows that the performance of reading at 5-degree eccentricity is significantly better than reading at 8-degree one under both text loading conditions. As for self-aware text loading, the loading users reported for 5-degree eccentricity is lower than 1 for 8-degree eccentricity under both text loading conditions. In specific, significantly lower scores found in 3 individual subskills, including mental, physical, and frustration. For overall experience using PeriText on AR, 6 of 8 participants expressed positive for our reading interface, while the other 2 users just think the ARS headset was too heavy for them to use. As for text positioning, all participants prefer displaying at 5-degree over 8-degree eccentricity. So, in conclusion, in this coursework, we presented the first study to investigate text reading efficiency using peripheral vision on a monitor display, and discovered that the title case transformation and word-wise typewriter effect with sans-serif found resulting in higher throughput when displaying multiple words at a time. We then proposed PeriText using these designs and evaluate the reading performance of PeriText against control text in the second lab study, and higher performance was found when using PeriText. Finally, we evaluate PeriText in real-life scenario. And finally, displaying at 5-degree eccentricity is not only outperformed, but also preferred over 8-degree conditions. And that's the end of my talk. Thank you for listening. I'm now happy to take questions.
Hello, I'm Michele Fiorentino from Politecnico di Bari. A very nice, interesting talk.
Thank you.
We ran similar studies in the past, and we are still working on this. So my question is just about the choice of putting in PeriText the text on the lower part, because also in working condition it may occlude streets or obstacles. So thanks.
Yeah. So for choosing placing the PeriText at the bottom is because if we put on the left or the right side, the character in the leftmost side and the rightmost side will be like in different eccentricity. So we want to avoid that condition. And for we put at the bottom over at the top of the PeriText is because some past research have concluded if we put the text at the bottom of the screen, it will given more high performance on reading. Yeah.
Thank you very much.
Thank you.
Hello, Clayton Kimber from Google Daydream. Thank you for the talk. I was wondering if you have the eye data on if users were deflecting to actually focus on the text rather than.
Yeah. So in the study 1 and 2, we conduct the study on desktop-mounted display. So it's use Tobii eye tracker to track the data. And what I mentioned is that if the eye positioning data is like have too much distance from the text, we will discard that trial. So that means we only preserve the trials that is user will focus on the text. Will focus on the central vision field instead of the text.
Yes. I guess my question was, did you see a lot of discarded data because of the?
Yeah. So in our paper, we also mentioned that about like below 10% of the trials have that conditions. Yeah.
Okay, thank you.
Thank you.